Hi everyone, this is Natraj. I'm back with another video. In this video, I'm going to talk about that configuring the Cloud SQL database flags PostgreSQL using Terraform. Configure the PostgreSQL flags. The Google Cloud SQL support the custom settings of PostgreSQL flags that can enable to configure and tuning your Cloud SQL database. For example, to enable the PostgreSQL slow log query to help that spot the performance problem, also you can tune the maximum packet size. So there is a more number of things will be there. You can tuning your performance based on your usage of the applications. Support the custom flags. So here in this URL, it will be containing the n number of flags based on that application performance tunings. So we can check it out that some of the things. So just I'm going to click this URL. Yeah, you can see here I'm type that max, randomly searching on it. So you can see here, so based on the max there is a n number of parameter flags is available. So we can choose either of one based on your application performance tuning. So next one is the Terraform. So in this video we can explore that what is a Terraform dynamic blocks or how to use them and just practice to follow. Switching to the Visual Studio Code. So one of my previous video I talk about that entire Terraform code with a detailed manner. If you are not watching this previous video, can you please watch it, that you will get the more idea. I can display that video informations in this page so we can check it out. I can only talk about that the few changes are modified in this course so we can see in the deeply. The first one is that the dynamic blocks. So the dynamic blocks to create the repeatedly nested blocks which in the resource. More or less it will be similar like for expressions. The dynamic blocks is iterate over the cloud resource or generated the nested block for the each element of the resource. You can see here I am using the for each. The for each is a meta argument. It helps to create the multiple instance of the defined resource. Also, the for each primarily work with set strings or map strings only. For example, when I creating the multiple subnets, we can specify the different CRD range for each subnet is created with the same resource block. In this for each, I pausing with that var.data_flags. So it is a set types, the each dot value only available in the property. So in case of map, it can possible to retrieve the both key and value used by each dot key and each dot value. You can see the content. So it is a body of the each blocks. Here I am using the Terraform lookup. The Terraform lookup function is the built-in function that's repeatedly that value of the map variables, also the listing of the object. It's a basic syntax of the lookup function is lookup map name comma the key comma the default value. So why I choose that lookup functions? It can add the unique default value in the lookup function to avoid the functional call error and lookup failures. The name is the variable, the only the referring with each dot value in the database underscore the flag variable. The default value is null. Suppose someone is haven't provided any value, it automatically taken from the null value. We'll moving to the variable.tf file. Yeah, we can see the variable. The variable is the database underscore flag. So the description I define in the URL for the Postgres flags. In the types you can see here I use a list. So the list basically hold the list of values. Also I use the object types. Why I am choosing the object types? Because I want to define the structural data with multiple attributes. One of the beauty call in the attribute is collections of the different types. You can use boolean, number, strings. This option is available, but this object below the name and value I defined. Here I am passing that both values are strings, but even though I am passing with the number also it can support because this is one of the parameter only I am going to enable. But in other case you are going with the opening the firewall, in this case you have to use with the number only. Okay, the default value you can say things just randomly enabling that Cloud SQL IAM underscore authentications, make it on. Also the max underscore connections also increasing with 100. We are at the Google GCP console page. Already I log in with my corresponding credentials. I'm going to click that navigation menu here. Then I can scroll down below. I choose that SQL. Yeah, you can see here my Postgres instance already I created. Just I'm clicking on it. If you scroll down below, you can see the configurations. There is a no database flag is set. So I'm moving to that my Visual Studio Code. So I open with a new terminal. Here I'm executing the Terraform apply command. Yeah, it asking the user input. Also you can scroll up. These are the settings, and these settings the data flag. These are that I'm going to enable. These are the parameters. So I can provide with yes. Now the modification is going on. Yeah, Terraform operation successfully completed. So I am moving back to my GCP console page. So we are already in the SQL page only. Just I'm refreshing this particular thing. Yeah, if you scroll down, moving to the configuration page, yeah, you can see a thing, the data flag is reflected. So whatever we defined, the two parameter it became here. So I hope this video will be useful to everyone. Thanks for watching. Bye.